Okay, the next essential skill that we're going to be doing in Integrated 1 is systems. So hopefully this video is helpful to you as we go through and practice this. There are basically two different ways that we're going to be doing systems, and it's graphically and algebraically. So I figured with this first example that we would actually do it both ways. So if we take a look at this, I'm going to go ahead and do this graphically first. So if I want to do this graphically, then what I'm going to do is I'm going to separate this equation. So on one side, I am going to do y equals, I'm going to go ahead and create a graph out of this, x plus 5 squared minus 6. If I go over to my graph, it looks like my hk is going to be at -5, -6. And if I plot that point, be able to be right there. Then using what I know that I can go right 1 and then up 1 to find the next point using symmetry. And then if I continue plotting more points, because I want to make sure that I run into the y equals 3, which is going to be the other side. So go ahead and plot a couple more points here, which I can do just by making a table. Alright, looks like I now have my points for this graph. And then just go ahead and do your best to connect the dots and make it look like the shape. So here we've got our parabola. Oh, missed my dot a little bit, but I think we get the point. Then on the other side, I would go ahead and separate that one as well. So rewrite this as y equals 3. Now I know y equals 3 is a horizontal line, so I would go to where y equals 3 on the y-axis, and I'm going to draw a horizontal line all the way through and across. Now if I take a look at this, I'm trying to use this graph to figure out what the solutions are, which really is going to be the points of intersection. So I see these two locations. But if I go back to the original question, notice that the only variable inside the black equation that was given to me, my original, there are only x's, which means my answer is only x values. So my solutions themselves are going to come from the graph. However, they are going to be written strictly as x equals, not as points, since the red and the green were used as a tool to help myself out here. So if I go through and I figure out where these are located, it looks like this is going to be at x equals -2 and x equals -8. So I would write those down as my two answers, x equals -8 and x equals -2. Okay, I already know what the solutions are going to be now because I've solved it graphically, but let's go ahead and do this algebraically. So I'm going to start from scratch again, go back to the original equation. So I have my x plus 5 squared minus 6 is equal to, and the other side was 3. Now you can choose what method that you want to do here. I think I'm going to undo this. So I'm going to go ahead and just kind of slowly start sliding things to the other side. So if I do x plus 5 squared is equal to 9, I'm going to square root this. Don't forget your plus or minus. The square and the square root cancel on this side, and I end up with plus or minus 3. Minus the 5 to the other side of the equation, I get -5 is equal to, x equals -5 plus or minus 3. I do have to separate these two answers out. So -5 plus 3 gives me the -2 that I got earlier, and then -5 minus 3 does give me the -8 that I found as well. Okay, moving on, so we want to go through and solve this graphically. I'm going to go ahead and do the exact same thing. I would separate out, so the left-hand side is going to become its own graph, and then the right-hand side is also going to be its own graph. So I'll get y is equal to -2x plus 10. Now for me, I normally like to graph the line first because I think it's a little bit easier. So now would be a good time to pause, See if you can graph the line and graph the left-hand side absolute value as well, and then check and see if you and I match. Okay, so based off of my graphs, it does look like that I have two locations where these graphs run into each other. And I'm circling them in black. Keep in mind that I am also only giving the answers that are x's because the question is only x's. So my solutions are each going to be x equals, and if I take a look at the graph, it looks like one of the x's is going to be at 4, and the other x is going to be at 0. Okay. Moving on, we do have a problem here, something that we've been doing fairly recently in class. We want to be able to solve both graphically and algebraically. So go ahead and pause. Want to be able to graph this. Remember, you may need to plot extra points to make sure that the graphs actually intersect, and you can find the location on the graph. And then we'll come back, take a look at the graph, and then we'll proceed with the algebraic portion. Okay, so here I have my graph done, and I can see that they intersect, but I'm not totally sure exactly where it is. So it's kind of an example of I should be able to solve graphically so I can find out where they intersect, but I'm not totally sure where that is exactly, which is where algebraically comes in. Also, I see that they only intersect in one spot. So when I go through and solve this algebraically, I do want to make sure that I'm just getting that one answer. All right, so if we now take a look at this algebraic method, I know to get rid of the square root I'm going to square, and it's at this point that I know by squaring 2x plus 1, I'm introducing a new variable that wasn't there in the beginning, which means chances are I'm introducing an extraneous solution. So I'm just going to be aware of that as I'm going through. So if I multiply this out, I know I'm going to do 4x squared plus 4x plus 1. So I just went through and drew out the boxes. Get equals 0 on this thing. So I'm going to move the x over, and I'm going to move the 2 over. Go ahead and factor this as well. And then solve. So I now get 4x minus 1 is equal to 0, and x plus 1 is equal to 0. If I solve these, I get x is equal to 1/4, x is equal to -1. Okay, taking a look back over at my graph, I know that they do not intersect at x equals -1, because at x equals -1, the green and the red are not hitting each other. There's my extraneous solution, so let's get rid of that guy. I do know that there is a point of intersection, and based off of where it's located, it's somewhere between 0 and 1, and 1/4 fits the bill. Okay, so we want to be able to solve both graphically and algebraically. So here we've got something back from integrated 1. We have two linear equations. You have to decide how you would like to approach this problem. You can either do substitution, you can do elimination. We still do need to be able to do the graphing portion of it. So I'm going to pause here. It's a good time for you to pause as well. And I'm going to graph the two and see if I can figure out if there is a point of intersection and where it's located. Also notice that this original question is two equations and two variables, which means I need answers for each of those two variables. Okay, after graphing, I do see that the point of intersection is kind of a nice location. And I do want to write it as a point this time, so it looks like we're at 2, 3, 4, 5, 1 as our solution. So I know that graphically my solution, written as a point because I have both an x and a y. Now algebraically, I notice that both of these equations are equal to y. If they're both equal to y, then I can actually just set them equal to each other. So I would rewrite the two equations equal to each other since they are both equal to the exact same thing. Now I notice that there's fractions in here, and if you're not bothered by them, then just leave them alone and go ahead and proceed. If you are bothered by them, then you can actually eliminate them if you'd like to, which I think I'm going to do. So I'm going to make everybody look like a fraction here. If I got a common denominator, that denominator would be 5. So I'm going to multiply everybody by 5 over 1. And then I'm going to simplify as I go. So if I take a look at the very first two, so if I'm multiplying this 5 times that, negative 2/5 x. Notice that the 5's cancel, I get 5 over 5. So I think I just get a negative 2x over 1, but the over 1's not necessary. Go ahead and distribute the 5 there. That is going to give me a 15. Distribute the 5 there. The 5's cancel again, so I get a 3x. And then distribute the 5 there. And that's going to give me a negative 10. I feel a little bit better about this now, so I would probably add the 2x to the other side. So it gives me 5x minus 10. Add the 10 to the other side, gives me a 25. And then if I divide, I do get x equals 5. Thank goodness, because that is the x value that I found earlier. Now, based off of the problem, I still have to find the answer for y. So choose the equation that you prefer from the beginning, not an equation that you have adjusted somehow. So I think I'm going to use the second one just because the coefficient is positive on the x, for no other reason. Okay, so now I'm going to go ahead and plug that 5 in. If I do that, those 5's cancel. I'm going to get 3 minus 2, which is just 1. Notice that the solution I get is the exact same solution I got graphically, which should happen because it's the exact same equation, you're just solving it a couple of different ways. Okay, on this next one, we want to be able to solve this algebraically, so we're not going to graph this one at all. Notice that they're both equal to y, so I'm going to go ahead and set them equal to each other. And I'm going to proceed the same way that I did on the previous problem. Now, we've been dealing with parabolas or combining parabolas and lines a lot recently. I think this is a good time to pause, see if you can work through the problem, and see if we get the exact same thing. Okay, so I went through and I've just solved for x so far. I'm not done. I still need to find y. So since I had x's on both sides of the equation and one of the x's is trapped inside parentheses, I knew I had to get rid of the parentheses, which was why I went through and I took this x minus 2 squared and turned it into x squared minus 4x plus 4. So I drew a box off to the side. Then from here, I went through and I distributed that negative 2 to everything inside and just dropped everything else down. I noticed that I have an x squared, I've got an x, I've got equal signs, which means I have my 3 choices. I could do quadratic formula, completing the square, or factoring. In this case, factoring worked, which is kind of nice. So I ended up with taking out my negative 2, make my life a little bit easier, get the numbers a little bit smaller here, and then went ahead and factored with x minus 6 and x plus 1. Find my 2 solutions then for x being 6 and negative 1, and then go back to the original equations and pick the one that makes you the happiest. I definitely prefer the equation of the line, so y equals negative 2x plus 15. If I go ahead and plug in my 2 values that I found, so I have x equals 6. If I plug in x equals 6, then y is going to be negative 12 plus 15, which gives me 3. So one of my solutions, which I can write up here in the corner, is going to be 6, 3. But I also know that there's going to be another one. Then I know that x equals negative 1 was my other x value. If I plug that in, I'm going to get a 2 plus 15, which is going to give me a 17. So I'm going to get negative 1, 17. So I do have my 2 points of intersection. Okay, so now here we've got some word problems, and this is really predominantly a review from Integrated 1. So go through, read the question, and we want to be able to extract the information that we need. So I see she made 17 ounces of a tasty drink by mixing, so we've got 1 container of lemonade with 3 containers of lime soda, 17 ounces. All right, so there's that one. But then I also have another one, 5 containers of lemonade with 6 containers of lime soda produce 58 ounces of another splendid beverage. Okay, so while we're going through and doing these, I think it's probably important to identify what variables that we want to use. So I think I am going to do L for lemonade. And for lime soda, I think I'm going to go with M, only because of the M in lime. You could do X and Y, it doesn't really matter. You just need to make sure that you identify them. So if I go through and I write an equation, it looks like 1 container of lemonade, so 1L plus, and then it was 3 containers of lime soda, so 3M, and that gave me a total of 17 ounces. So if I add those two together, I should get 17. So there is my, excuse me, there is the green information written as an equation. And I want to go through and do the same thing with the yellow. So I've got 5 lemonades plus, in this case, 6 lime sodas, and that gives us 58 ounces this time. So then, with our 58, this is now going to be our yellow equation, or from our yellow information. All right, from here, notice that the variables are stacked up on top of each other, and the equal signs. I think I'm probably just going to do elimination. Which one do I want to get rid of? I think I'm going to get rid of the M. So I'll take the entire first equation, and I'm going to times it by -2. And I'm just going to stack it up underneath the other one that was here. Once I have that, I should be able to add straight down. My M's are going to disappear, and then if I subtract here, that's going to give me 24. So notice that my equation now just has a single variable in it, which is ideal, and I was able to solve for L being 8. Then choose the original equation that you like the best. I think I'm going to take the first one just because the numbers are smaller, and I'm going to plug in what I know. So I know that L is 8. And then if I solve, I'm going to subtract and then divide. And then just make sure that you answer the question. So the question was, how many ounces are in each small container? All right. So in lemonade, there are, and however many answers we got for L, so which is 8, there are 8 ounces. And in the lime soda, there are, and then whatever our answer was that, which was 3. So identify your variables, make sure that you write equations appropriate to the situation, and then answer the question. Okay, so now we've got some inequalities that we need to deal with, but if we're going to do this graphically, I'm going to just go ahead and treat them like they're equal signs. So if I take a look at the first one here, so let's do that guy. If we do that first, then I'm going to go ahead and just rewrite it as y equals -3/4 x minus 1 squared plus 6. And now we know how to graph this, so go ahead and take a minute and graph each one of these separately. Actually, scratch that. Let's just do the first one. Okay, so I plotted my HK at 1,6, and then I used my -3/4 to help me out here. So I went right 1, and then it's negative, so I went down, and I went down 3/4. Before I connect the dots on this, I want to pay attention to the inequality symbol. The inequality symbol does not have an equal sign, which means when I sketch this, I am going to do this with dashed lines or with a broken line. So when you go through, I'll make sure that this is dashed. And it should be aiming down or pointing down. Oh, that one's off a little bit. Let's get rid of that side. Since your A is negative, we knew that the parabola was going to be facing down. All right, so we've got that one. And then I want to do y is less. Okay, so here's my trick for shading or graphing these. I put my cursor right on the HK or my pencil, and then I read the inequality to myself. And if it says y is less, well, y values go up or down. If it's less, then that means that we're going to be going down. So I'm going to be shading down from the vertex, which means I'm actually going to be shading inside the parabola. So I'm in here. And I'm just going to go ahead and do it in yellow so I don't get it confused with my other graph that's going to be coming up here in just a second. Okay, so there's that one. Then I'm going to go ahead and graph the other one as well. So y equals x minus 7. So if I do y equals x minus 7. All right, so I know where that's going to start, and I know it's going to have a slope of 1. So go ahead and pause, and let's go ahead and get that graphed. Okay, so you'll notice that I've got my dashed line in because the inequality doesn't have an equal sign on it. I'm going to go ahead and put my pencil on the y-intercept on this graph, so the place that I would normally start graphing this line. And then I read the inequality to myself again. So as y is greater, well, y is up or down. If it is greater, then I am going up. So if I'm going up, then I know that the shading for this is going to be above the line. So what we need to do to find the solution to this is find where the graphs overlap. So it's going to be where the yellow and the blue come together. So what I can do is I can erase the extra shading that I just did, or I can just take my pencil and darken in the area where the overlap is occurring. And since I do have some yellow there, I want to make sure that I'm showing that I'm either keeping all of the yellow or getting rid of the extra. So let's grab our yellow highlighter again, and we know that this is also going to come down here. So my shading, or my solution to this, is going to be the yellow region. And I should probably continue my parabola so we can see it. So there is where my shading is for this solution. Okay, and then our last one, taking a look at this graph. This one's a little bit different. So here we've got our f of x, and we want to be able to find out where f of x is equal to -2. Well, just as a reminder, f of x is a replacement for y. We know that from integrated 1. So basically we want to be able to graph y equals -2. All right, so if I go over to my graph, I know where y equals -2 since it's that horizontal line right there. So in order to solve the first equation, if I take a look back and just look carefully, the only variable inside that first equation is actually x. So much like what we did earlier, where x was the only variable, so x is the only answer, then that's what we're going to do here. So our solutions are going to be x equals. So if I take a look at the graph, I want to find where the red hit the graph that was already there. So it looks like it's going to be at 0 and at 2. X's only. So 0 and 2. So x equals 0, x equals 2. Okay, now the second one, this is kind of the same idea. Remember that, much like the first question, f of x is the same thing as y. So we want to be less than or equal to -2. All right, so I want to know where I am less than or equal to the red line. Well, less than or equal to on a y value means that we are down. So what I'm looking at here is I'm looking at this region underneath my line. So if I take a look back at the original question, I want to know where f of x itself, so the black graph, is in the red shaded region. So if I take a look at that, I already know where these values are located. I know that this is at 0 and this is at 2. Notice that the black portion of the graph that is under the red line is actually in between those two things. So my answer is going to be that my x value is in between those two values on the graph. So it's just like using my answer from part A, but now I do need to include the graph as well. I hope this has been helpful.